Hi class, for this sections we want to talk about how the derivatives affect the shape of the graph. If you know derivative, if you understand derivative, the derivative is the slope of the tangent line, right? So it's really easy for us to visualize it. If the tangent line is positive, if the slope of the tangent line is positive, then the function increases. If the slope of the tangent line is negative, then the function is decreases. Okay, so we have something called the ID test, is for increasing and decreasing tests. So f prime of x positive, then f is increasing. F prime of x negative, then f is decreasing. So don't forget f prime is the slope of the tangent line, right? So take a look at the first example that I have right here. We just want to use the ID test to see where the function increases and where the function decreases. So how do we do it? First, you need to take the derivative, and then I need to find the critical numbers. So the critical numbers, in this case, you see I just factor. In this case, the critical numbers are 0, 2, and -1. I then put in the numbers. So I have the -1 here, I have 0 here, I have 2. Then I'm just going to test the interval by plotting the points, right? So from -infinity to -1, I pick -2. When I take -2, I plug it in here, and in here. I ended up with a negative, and a negative. You see, I don't even care about the number because all I care about is positive or negative. Negative times a negative times a negative gives you a negative. From -1 to 0, I pick the point -0.5. Once again, I plug it in, I ended up with a negative, and a positive. When you multiply, you get positive. From 0 to 2, I choose 1. I plug it in, plug it in, plug it in. You get a positive, negative, positive. Multiply, we get negative. Pick a point, plug it in, positive, positive, positive. So I ended up with a positive numbers. So I have from 0 to from -infinity to -1 is decreasing because it's a negative values. From -1 to 0 increasing because it's a positive one, and so on. So that's how you figure out the interval of increasing and decreasing by using the ID test. Now, the local extreme values, we have something called the first derivative test to figure it out. Very simple. You find the critical numbers. Of course, f has to be continuous. And then you see if f prime changes from positive to negative. So you see right here, from positive to negative, then we have a local max, right? So even if you can't memorize all of these condition, you can visualize it. If I go from positive, negative, I have a max. If I go from a negative to a positive, I have the min, right? So that's how the first derivative tests work. So local max, you see that? Positive, negative, negative, positive. Okay, and you see right here, no max and no min. Because f is positive to the left and right of C, or negative to the left and right of C, then f has no local min or local max. Okay, so let's take a look at the same example. So for the same example from the previous work that we did, you see that f prime changes from a negative to a positive at -1. Therefore, if you plug it in, you get the local min. Okay, and then we go from a negative. I'm going to go back and show it to you. You see, we go from a negative to a positive at -1. Okay, so and then we go from a positive to a negative, a positive to a negative. So this is right here is a max. Yeah, this is the min. From a negative to a positive, you have a min again. So that's why I have it at these point right here, local min, because from negative to positive, local min. Max is from positive to negative. And don't forget you plug it in the original to find the local max and the local min. All right, moving on to the second derivative. So what does the second derivative say about f? Is that's when we take care of concavity. So you see right here, we have concave upward and concave downward. So how I remember is we are smiling or frowning. Okay, so if the graph of f lies above all its tangent line, then it's called concave upward. Right here, up, up, up. And now these are the tangent line, and you see it lies below all the tangent line. So that's why we have concave downward. And then we use the second derivative to test for concavity. Okay. Once again, this is kind of easy to remember. If it's positive, then the graph is concave upward. If it's negative, then the graph is concave downward on the interval. Okay. And then we have the second derivative test and for the max and the min as well. So let's go all of these. Oh, by the way, I'm sorry, I skipped this part. Point B is called the inflection point. If f is continuous there and the curve changes from concave upward to concave downward, or vice versa, then we have the inflection point of inflection. So you see right here, this is the curve. So first, I find the first derivative. Then from the first derivative, you can get the critical numbers, right? Now, I also take care of the second derivative as well. So from the first derivative, we have the critical numbers are 0 and 3. We set it equal to 0, we solve it. Now we're going to use the second derivative to evaluate f double prime at these critical numbers. You see right here, we have f double primes of 0 equal to 0. Second derivative at 3 equals to 36, which is a positive. Okay, so we have a local min at 3. Okay, and then the local min right here, I plug in the original. That's how I got -27. Okay, now we have 0 here for 0, so we can't do anything about this point right here is inconclusive. We need either a positive or a negative number. 0, we can't do anything. Now for concavity, remember, we want to check for positive and negative. So once again oh, by the way, we are checking the second derivative here. So that's why I got the 0 and the 2. The 0 and the 2 is from the second derivative right here. 0 is for this one, 2 is for this one. So these two are the possible inflection points. Okay. And then once again, I'm checking the second derivative. I get a positive and a negative and a positive. So up, down, up, right? Inflection points second derivative for inflection points. So that's when we go from a positive to a negative, which is upward to downward. Bingo, you got one inflection. This one right here also changed from downward to upward. So we got another inflection point. Okay, so I repeat, for the first derivative, we taken care of increasing and decreasing. For the second derivative, we're talking about concave upward or concave downward. And then for the first derivative, you have critical numbers. For the second one, you have possible inflection points.